Okay, students, same thing as yesterday, except now we're doing phase 2. All right, we're doing the area of circles and sectors. So to get started, we're going to fill the correct parts of each ratio in the given proportion. So let's just focus on this. All right, there's more we're going to do, but realize this is the circumference. All right, arc, let me do it like this. Arc length corresponds to circumference. It's a part of the circumference over the whole circumference. Similarly, with this part right here, this is area of a circle, and what corresponds to that, it's sector area. All right, so remember, these last few lessons, it's really about part of what we're looking for in the circle versus the whole part of the whole circle. All right, so now we're gonna just we're just gonna focus on arc length now. So realize for arc length, we have central angle over 360 equals arc length over 2 pi r is how we typically write it. But again, remember, we can write this as pi times diameter or just circumference itself. And some things to remember: CA, that means central angle, and AL we define as arc length. All right, hopefully you know what R and D and C mean. All right, those radius, circumference, and diameter. And the next, very similar. Again, you can't get these confused. The details matter. This is central angle over 360, and then sector area relates to pi r squared. All right, where CA again is central angle, and this time SA means sector area. All right, so this is just kind of an overgeneralized review of stuff we've been doing the past few lessons. All right, so we're gonna find out, start off. I might die during this lesson. If I die, hopefully you can finish the rest of the notes on your own. We're going to find the exact area of the blue sector shown in the figure to the right. So again, we're finding area. So we need the central angle over 360, and that equals the sector area, which we're finding, over pi r squared. The central angle is 60, and the radius is 8. I'm looking for sector area, so I'm going to replace that with the x. All right, so then it's all about reducing. 60 goes into 360 6 times, so that becomes 1 over 6, and then we have a 64 pi. All right, then from here it's just cross multiplying. I'm going to get 6x equals 64 pi. Divide both sides by 6, and x equals 64 pi over 6. And then last thing I'm going to do is reduce this, and this becomes 32 over 3, and then I have a pi. That's the exact area. All right, exact area of the blue sector. And I could plug it into the calculator and get some kind of rounded answer. All right, now this time the sector area is 8 square inches and the radius is 12. We're going to find the central angle. So this time we're finding something different. All right, central angle is actually what we're finding this time, 360 sector area over pi r squared. All right, so carefully plug in stuff. Sector area, I'm going to plug in 8 pi for that. Radius, I'm going to plug in 12 right there. So very carefully, I'm going to call central angle theta over 360. Sector area is 8 pi. And then the radius, plug that in. All right, so let's just do some simplifications. The pi's cancel out. So next I'm going to have theta over 360 equals 8, and that's 144. All right. and then I can technically reduce right now, but let's just go ahead and cross multiply first and then see what happens. We'll go from there. It never told me I needed a, actually move it right like this. It never told me I needed exact area. And as I solve for theta, it's 20 exactly. Hooray! Central angle was 20 degrees. All right, oops, that's a horrible degree symbol. 20 degrees. All right, and then cruising right along, the area of a sector of a circle is 50. So we got a sector area of 50 pi, and we got arc length of 50 centimeters. Now we got to find the radius. Ooh. Okay, so we actually got to use this first one that we used up here. All right. Let's go ahead and write arc length over 2 pi r, and then sector area, which is 50 pi. Actually, it told me the arc length. Excuse me. Hold on. Time out. Let's just write the formula first, then we'll plug in everything. Arc length, sector area over pi r squared. All I did was rewrite the formula from the very top. All right, now I'm very carefully going to plug in sector area, boom, right there. And then I'm very carefully going to plug in arc length right there. All right, so I'm going to get 5 pi over 2 pi r equals 50 pi over pi r squared. Okay, ooh, this problem is going to be literally insane. First, what I'm going to do, since I have pi in both sides in the numerator and denominator, I'm going to simplify that. All right, so I'm going to have 5 over 2r equals 50 over r squared. All right, now, very carefully, I'm going to cross multiply. I'm going to get 5r squared equals 50 times 2, 100r. All right, now I'm just going to take this very slowly, step by step. I'm going to divide both sides by 5. Again, reverse order of operations, so I'm going to wait to do some other things. All right, now I have r from both sides, so don't take the square root. I know you might say, well, let's take the square root of both sides. No, let's just divide both sides by r, because then realize that this r is going to cancel with that exponent and boom over there, and then r is just 20. Okay, so some intense algebra. If you've been missing algebra, you probably enjoyed that problem a lot. All right, so the radius would be 20 centimeters. All right, now let's knock out these two problems right here. We're going to find these exact areas of the shaded region. So really, we got the big circle. So the area of the big circle, remember, it's just pi r squared. So it's going to be pi times 27 squared. 27 squared. So 729 pi. All right. Then we got the baby circle. Actually, let me call it the little circle. Area of the little circle is pi r squared. Gonna get pi 20 squared, 400 pi. So the exact area of the shaded region is just going to be the area of the big circle minus the area of the little circle. All right, we just want to remove the inner circle. So it's 729 pi minus 400 pi. And it's 329 pi. All right, that's the exact area right there. Cool beans. Next problem is, well, first thing we got to realize, let me focus on this square first. Oops. All right, the square. Well, since the radius is 4, that means the diameter is 8, which means that this whole thing, the whole side of the square is 16. Then that's 8 as well. All right, so the area of the square, remember, it's just side length squared, so it's going to be 16 squared or 256. All right, so when we're doing these crazy problems, we just want to start off with some basic things we know, such as the area of the square. All right, the area of the circle, one single circle, well, area of the circle is pi r squared, which is going to be pi 4 squared, 16 pi. All right, so that means the 4 circles, add them all together or just multiply by 4, it's just going to be 4 times 16 pi, or 64 pi. All right. So then the area of the shaded region is just going to be the area of the circle, or square, excuse me, minus area of the square minus 4 times the area of a single circle. So 256 minus the 64 pi we already calculated, and bada bing, bada boom, that's the exact answer. Anything you plug in the calculator